All right. Well, hi, I'm James. I'm very excited to be here to talk to you. In my free time, I like to automate Halloween decorations and also convince LLMs to write mysteries. So this is all about whodunit. Very excited to talk to you about it because it all started with family game night. There are a lot of mystery games out there that are a lot of fun, but you'll play enough and realize that most of them are either logic puzzles or you spend more time running around the board than Scooby and Shaggy do running from the abominable snowman. So I wanted a game where the mystery was the focus, and I wanted to be able to play it, which meant I couldn't write those mysteries myself. And I figured LLMs are so good at sounding good, maybe I could get one to also be logical and engaging and write fun mysteries. So I set out with a few goals. I wanted to develop a mental model for working with LLMs. I wanted to test a few of the top tier LLMs in their Go libraries and see where they were the same and where they were different. And I wanted to convince those LLMs to write mysteries. So the first attempts, they sounded good, but they were not logically sound. So with some trial and error and mostly error, I ended up getting to a pretty good point. But what's in a mystery? Well, I wanted to have a scene that introduces the setting, which are the characters and locations where you might find clues. Those clues are the hidden bits of information that you need to find in order to reach the solution. The solution is a series of questions like who did it, where, and why. And it ends with a denouement that's a convenient wrap-up that Fred, Velma, and those meddling kids would enjoy. And this would all be played on paper, where players would take turns reading clues, and eventually once you'd read enough and you thought you had it solved, you could then check against the solution, hopefully get it right, and read that denouement. So how could we use LLMs? Well, pretty much all of the libraries out there, they boil down to this idea. You have some function that you can call that will generate text. You pass in an input, it gives you an output. Whodunit was nice because it was all text-based, so it got to avoid some of those problems. But the input that you give, you have a system prompt. The system prompt is the set of rules that you want to give the LLM to follow, and then you have the prompt itself, which is any information you might want to pass in for that particular run. For whodunit, everything was actually structured inputs with JSON, which the LLM handles quite nicely. So using those tools, the first attempt was an all-in-one mystery where I asked the LLM to write a mystery that needs a scene, a setting, clues, a solution, and a denouement, and to match a particular output format. And the problem is that the mysteries just didn't make sense. There were contradictory clues, everybody looked guilty, and the solution had a lot of information that wasn't even available in the clues. So the only way to reach the solution would just be to make a wild accusation. But the output did follow the example format, so that was good. And the mysterious, the text that it wrote did sound good. It didn't make sense, but it was mysterious. There were cliches, there were cheeky names like Tammy the Teller who works at the bank. So it was a good start. But I realized as I was adding more rules to the prompt every time the mystery went off the rails, the prompts were getting longer and the mysteries were actually going down in quality. So that led to the first improvement, to break it down. The problem is that the longer the instructions got, the more information that the model had to keep in context and the more details that were there that it could forget. So just like us humans, breaking it down from a big problem into smaller individual problems, each step had fewer rules, there was less to confuse the LLM. So it looked a little bit like this. First, it would write the scene, then it would write the setting, then the clues, then the solution, then the denouement, and each time it would carry all the previous steps information along. But this ran into a software engineering problem because we went from one API call to many API calls, and each of those API calls could fail for a number of reasons. It could be service disruption, API key throttling, could be malformed output from the LLM, and so in order to address that, I reached for a workflow management system. I like using Temporal. All the LLM calls became activities. Temporal did the heavy lifting to retry automatically if there were any errors. And it gave a lot of confidence that once you started generating the mystery, it would eventually finish instead of getting partially complete mysteries. And at this point, the LLM followed the rules much better at each step. The logic was still off, though. The characters, they all seemed guilty, and the solution seemed arbitrary. It's like if your Blue's Clues handy-dandy notebook said everybody did it. And I realized that order matters because LLMs write one word at a time, and I asked it to write the scene, then the clues, then the solution. So it was writing clues before it knew who did it. That's why the solution seemed arbitrary. So I turned it upside down, and I had it write the setting, then the solution, then the clues, and then the scene and the denouement as the bookends. And that's when the mysteries started making sense, but there's still room for improvement. The biggest game came when I asked for the LLMs to please try again. Turns out that you can ask the LLM to review its original prompt and input and output and update the output so that it better matches the original prompt. Looks a little bit like this. You ask it to review all the information, update the output, hopefully make as few changes as possible. And you take that as a new input, you pass it into that same generate function, And what you get is an output that is a little bit better at following the rules that you originally sent it. Now, I wanted to print mysteries for all of you, but I couldn't do that to the trees, so I also couldn't leave you empty-handed. If you go to whodunit.rip, you can solve AI-authored mysteries. You can play by yourself or with friends. If you do solve a mystery, there is a CTF challenge flag available for you. And whodunit.rip is made in Go. It's a server-side rendered web app. It uses Temporal compiled HTML templates. It uses HTMX for on-page interactivity, and it uses Temporal as a turn-based game engine. If you are interested in any of these technologies or have used them, please come talk to me. I'd love to hear about your experience. Good, bad, mysterious, whatever you got. Thank you very much. My name is James Heller. I hope you enjoy solving AI-authored mysteries. Hope you have a great rest of the GopherCon. And just one more thing. In the mystery of who's having the most fun in New York City, that's easy. It's the Gophers with the laptops here at GopherCon. Thank you.